Hey everyone, welcome to Unit 1, Day 13. Today we're going to be talking about the function, its definition, and what it means for a graph. So yesterday we talked about the definition, what the precise definition of a function was, and we talked about what that meant for tables, right? So how do we look at a table and figure out if a table represents a function or not? We're going to do the same thing for a graph. So how can we just look at a graph and tell if something is a function? All right. For review today, what we're going to be doing is talking about evaluating and solving a function again. It's going to be on the next test again, so it's not a bad thing to practice. Okay, so this is one of the first things that we did. We learned how to put an input into a function machine and see what we get out. So when we have a problem like this, they tell us the name of the function here is f, the input is x, and the rule is 5 times x plus 4. So when they say something like find f of 4, okay, this means the input is 4. I'm going to take this 4 and I'm going to plug it in wherever I see an x. So f of 4 equals 5 times 4 plus 4. All right, so the x got replaced with the 4. And then I use my order of operations. So I'm going to do multiplication first. So I would do 5 times 4, which is 20. So now I have 20 plus 4. And then I'll do the addition. 20 plus 4 is 24. So this is telling me that if I put a 4 into my function, I'll get a 24 out. Right? So input 4, output 24. All right, so let's look at this next one, right? Because we should be able to go both directions through a function. So again, they tell us the name of the function is f, the input is going to be x, and the rule is negative 2x minus 4. And this time it says find x, right? So they want us to find the input this time. They're not giving us the input. They want us to find the input when the output is negative 6. So this is an output. Okay. So that means I want to do negative 2x minus 4, and when I do this negative 2x minus 4, I want to get a negative 6 on the other side, right? I want that negative 6 to be the output. So to figure out what number to put in for x, to make that happen, I'm going to use my equation solving skills, and I'm going to start by adding 4 to both sides. Okay. So the 4's will cancel there. We'll be left with a negative 2x, and then negative 6 plus 4 is negative 2. Now since this is multiplication, negative 2 times x, I'm going to undo that multiplication with a division of negative 2. And whatever I do on one side, I have to do on the other. So the negative 2's will cancel, and I'll finish it over here. We'll be left with just x, and then negative 2 divided by negative 2 is a positive 1. So this is the input. The output is negative 6. So it's saying when I put a 1 in, I'll get that negative 6 out. And that's the value of x they wanted to find. Okay. All right. So that concludes the review. Let's get back to talking about a definition of a function here. So remember from yesterday, right, we said the technical definition of a function is a relation from a set of inputs to a set of possible outputs where each input has exactly one output. So what does this mean on the graph? Okay, so let's say we look at a particular input. So here's my graph, and it's this blue wave, and I'm going to look at an input of 1. Okay, so if I go to 1, let me choose a different color here. A little bit more, I want to be more visible, right? So go with green. So let's say I choose an input of 1, and I go up to my function here, right? So when I put a 1 in, it looks like I get a 1 out, right? So remember we did this with the graphs before. So when I put a 1 in, I go up to where my function is, and I can see the output by tracing it back to the y-axis. So 1 goes in, I trace back to the y-axis, and I see where I'm at. I'm at 1. Okay, so 1 gets a 1. Now the question is, does 1 get anything else? Right? So I might look anywhere else where x is 1, right? So if I go down, I don't hit any other part of the function down here, and if I go up, I don't hit any part of the function up here. So from what I can tell from the graph, when I put a 1 in, I only hit this blue wave one time, and when I do, I get a 1 out. So that means that there's only one input and one output for 1. So an easy way to tell if something is a function is to look at a vertical line. Okay, and let me draw this vertical line in here. Let's say I take a vertical line like this. And then I can move that vertical line from side to side like this. And you'll notice that as I move it, it's going to hit the function in a particular location. Like this one will hit here, but it only hits the function once. Okay. All right. So if I were to grab this and move it from left to right, you'll notice that no matter where I move this vertical line across my graph, it's only ever going to hit that blue wave one time, which means no matter what input I pick, there will always be just one output. That's how I know this is a function. Now let's talk about this function. Okay, this one is not a function, and I want to show you why it's not a function. So I'm going to come over here and I'm going to pick -3 as my input. Okay, so -3 is my x value, it's my input, and I'm going to go up to where the function is here, right? So I go up to here and I hit the function, I trace it back to the y-axis. So when I put a 3 in, I get a 1 out. But notice that if I go down, remember that vertical straight line, if I go down, I also hit the function here at -2, right? So if I hit the function again, I trace it back to the y-axis, I hit -2. So when I put a -3 in, I could get a 1, or I could get a -2. And if I were to drag my vertical line over here, right, you'll notice that there are several places where I put that line, and you'll notice like if I put it here, it hits 1, 2, 3 times. It hits that curve 3 times. If I move it, if I move the function, or if I move that vertical line over here to, let's say, 1, if I can get it to line up, right? So even if I move it here, you'll notice 1, 2, 3, right? So for that input, I could get 3 separate outputs. All right, and remember, a function can only have one output per input. All right, so that's how we tell if we have a function or not. Now let's try it again on some other functions here, and let's see what we've got. Now it says, which graphs below are not functions? And if you think one is not a function, describe an input that has more than one output. So in other words, if you don't think it's a function, prove it. All right, and that's exactly what we're going to do here. So I'm going to go to one that I think is not a function. And let's see, so I'm just kind of scanning these graphs. I think this one is not a function. Here's why. If I go to an input of -1, so I'm going to say x equals -1, then f of x equals, well, let's see. So if I go to -1, I hit the graph right here at 1, or I could keep going up and hit the graph again here at 3. So if I put a -1 in, I could get a 1 or a 3, and that violates the definition of a function. Okay. Now if I were to come over here to this one also looks like that other one I talked about on the first page that might have more than one input or output. All right, so let's go over here. Let's go to -1 again. All right, so I'm going to say x equals -1. What could f of x be? Well, let's see. It could be 0, right? Because the blue function hits right on the x-axis, so it could be 0. If I go up, and then I hit here, it looks like a little bit before 2, so maybe 1.8. And then if I go down, I hit here, and I go back, and it looks like it could be at -1.8. So this input produces 3 potential outputs, and that would violate the definition of a function. Okay. Let's go back here to this first one. This one looks like a parabola. We've seen this before. I'm not seeing anywhere where I can get more than one output. So for instance, if I were to pick 2 here, I would go down to where the function is, and I trace it back to the y-axis. And if I were to keep going down, I don't hit the function again. And if I were to keep going up, I don't hit the function again. So it only hits in one place. And no matter where I do that at, I'm only going to hit that parabola once. So this is a function. Okay. Let's try it for this one too. So let's go to 1, and I'm going to go up. I hit the function right here, and I go over, and it's a little bit before 2, so that's fine. But if I keep going up, I don't hit the function again. And if I keep going down, I don't hit the function again. And if I were to do this anywhere else, like if I went over here to 3, I hit the function once here at -2, but I don't hit it again. Right? So this one is also a function. And again, I would recommend, if you have like a ruler or a straight edge or something where you can just draw in vertical lines, what you're trying to find is a place where if you drew a vertical line, you would hit that function more than once like we did down here. Okay. This one, some people might think, well, this looks like an issue maybe, so if I go to 2 and I go down, I hit the function here at that vertex, and I would get an output of -1. But if I keep going, I do not hit the function again, going up or going down. And it seems like that would be true at any other place on the graph. So this one is also a function. Okay. Now remember, I did these two because I didn't think they were functions, and I certainly found that they had more than one output at a particular input. So let's go ahead, let's find the other ones that are not functions here. And I think this one is not a function. So I'm going to go to 1. Okay, so I go to 1, and notice I hit the function, right? So when x equals 1, I immediately see that f of x could be 0, right? Because if I trace that back, that's where it hits the circle. So if I trace that back, it goes to 0. And if I were to continue up, I would hit it again at 2. Right? So when I put in an input of 1, I can get 0 or 2. Now if I go over here, this one I also think is not a function, so I'm going to go to 3. Let's test out 3 and see what happens. I go down to where my function is, I hit it here, and then if I go up, I hit it again. Right? So at x equals 3, f of x equals -1, right? That's this one, or 2. So again, 2 possible outputs for this one input on these two. So these are not functions. Okay. All right, guys, that's enough for today. Give the practice problems a try. Let me know if you have questions in the Zoom chat. Have a great day.